Welcome to Lesson 50 of my Algebra 3 Advanced Mathematics students. We are in Trigonometric Functions today, and we do not have any other parts, so we don't have an A and a B, we just have this one section. And we're going to use our unit circle chart to solve the problems for our trigonometric functions. So this means we don't have to worry about drawing a reference triangle. It's all kind of laid out for us. It really does help a lot. So let's just jump right into 50.1, and we have the sine of theta is equal to 1/2. We have to find theta. That is what we're trying to solve here. And we are given that theta lives between 0 and 360 degrees. So that's great because that's exactly what our unit circle depicts, is one rotation around the Cartesian coordinate system of 0 to 360. So we can easily do this. Now, when I look for the sine, that is 1 over square root of 2, I see no square roots of 2 in the denominator. And then I remember, oh, wait, we have to rationalize this fraction, right? We can't just do 1 over square root of 2. We have to actually get rid of the radical in the denominator because that's how you write a fraction. That's what you do. So we multiply everything times square root of 2 on the numerator and the denominator, and we end up with the square root of 2 over 2. So we're going to look for the sine that has square root of 2 over 2, and that will be our degree of measure. So remember, this is positive, so that's what we're looking for. So here is a positive. Remember, it is cosine sine, right? It's alphabetical order, if that helps you remember that. So here's 1, and that's on the 45 degree. So theta is equal to 45 degrees. Let's see if we have any more. So square root of 2 over 2. Here's another one, and that's 135. It's positive. So let's see if there are any more. Well, that's square root of 2 over 2, but that's negative. And then square root of 2 over 2, but that's negative, right? And it has to be in the second position. So our only degrees of measure are 45 degrees and 135 degrees. How easy was that? We only had to do a little bitty teeny tiny bit of math, and then we just had to look on our chart. Not so hard. If you haven't downloaded your chart, or if you haven't found one on the internet that you can use, you can make your own by using the reference triangles that we've been using all along. So you can always put them together and make your own chart if you can't find one, or if you're not a part of the Jupiter Red class where you can't download it. Also on our unit circle chart at the bottom, I've given us the values for sine, cosine, tangent, cosecant, secant, and cotangent, so that we have those references handy also. That will help us when we need to flip these, so we know which ones we need to flip. Right. So let's look at 50.2. All right, so here we need to find theta. That's our unknown that lives in one rotation of the Cartesian coordinate system. So that's awesome. So I just shortened given that to GT. So given that it lives there. At first, this looks a little scary. You're like, okay, what do I do? It's just an equation. It's just an equation. It has an equal sign. It's just an equation. What do we do with an equation when we have all these moving parts? We think about our rules and our operations. So if we have this whole number here, we can subtract it from both sides. We want to isolate theta, right? So that's what we're going to do. So now we have square root of 3 times the secant of theta is equal to -2. What do we do when we have a pair of factors? We divide by one that we know. We know square root of 3, so we're going to divide by that on both sides. So now we're looking for the secant of theta that is equal to 2 over the square root of 3, and that will be our degree of measure for theta. So the secant, what is the secant? It is the opposite of the cosine. So we are going to look for the first, I'm going to erase this. We're going to look for the first position here that is equal to, we're going to flip this, we're going to look for the cosine of square root of 3 over 2 that's negative. That's what we're looking for. Cosine of theta, that is the negative, because secant is the opposite of the cosine. So we're just going to look for this one. That's going to give us our degree of measure. So the negative square root of 3 over 2. So let's find that. First position, here's 1. Negative square root of 3 over 2. Here's another one. Negative square root of 3 over 2. I don't see any more. So theta is 150 degrees and 210 degrees. That's it. That's all you have to do. Reconcile it down to where you have, this is your x. So put this on your x. And if it's secant, cosecant, or cotangent, flip it to find its partner or its opposite. Okay, let's look at 50.3. I'm going to move this up just a hair, but we'll come back to the unit circle as we need to. Actually, I can just move it down. I'll just move it down with our problem so we don't have to move much at all. We can roll this back up. That helps a lot. All right, so now we're going to look for 3 times the square root of 2 plus 3 times the cosecant of theta equal to 0, given that it lives between 0 degrees and 360 degrees. We begin by solving the equation for the cosecant of theta. So we do the same thing. We subtract this from both sides. So we get 3 times the cosecant of theta, that is equal to negative 3 times the square root of 2. We have a known. We divide. So now we have, we can factor that out. So the cosecant of theta, that is equal to the negative square root of 2. Put that over 1 because we have fractions, right? So we need to have that over 1. Cosecant, what is that? Cosecant is the opposite of sine. So we want the sine, that is negative 1 over square root of 2. That's the one we're looking for, and that will be our answer for theta. So all we need to do is look at our chart for the negative 1 over square root of 2. Oh, and then we remember, oh wait, we've rationalized all these. There are no square roots in the denominator, so we just need to multiply times square root of 2 over square root of 2. And that's going to be the negative square root of 2 over 2. So that's the one we're looking for. Let's look for that. Negative square root of 2 over 2. And that's going to be in the sine position, so the second position. All right, here's one. That's 225 degrees. And here's another one, 315 degrees. So our theta is going to be 225 and 315. That's not so hard. You guys can do all of this stuff. You already know how to rationalize and normalize your denominator when it's a radical. We learned that a long time ago. Now you just need this little handy chart to help you find it faster so you don't have to keep drawing those reference triangles. And that's what this is for. So easy peasy. Make sure you have all the notes. If I went too fast, just rewind and pause as you need to get it all down. And that is all we have for lesson 50, trigonometric functions. Easy peasy. See you guys in lesson 51.